Imagine a tiny creature, invisible to the naked eye, capable of breaking down plastic. In 2016, scientists in Japan discovered Ideonella sakaiensis, a bacterium that digests PET plastic. This discovery ignited hope for a cleaner planet. Plastic waste piles up in landfills and oceans, threatening marine life. This tiny bacterium offers a potential solution. It symbolizes hope and the power of nature to heal. A new chapter in the fight against plastic pollution. So how do these microscopic marvels actually work? Ideonella sakaiensis produces two special enzymes that act like tiny scissors, snipping the long chain-like molecules of PET into smaller, digestible pieces. Think of it like this. Imagine trying to eat a giant plastic bag whole. It would be impossible. But if you had a pair of scissors to cut it into smaller pieces, you could at least start to break it down. That's essentially what these enzymes do. They break down the PET into smaller molecules like terephthalic acid and ethylene glycol. These smaller molecules are then absorbed by the bacteria as food, providing them with energy to grow and reproduce. The process is remarkably efficient. In laboratory settings, Ideonella sakaiensis has been shown to break down PET plastic at a rate much faster than previously thought possible for natural processes. This discovery was met with both excitement and a sense of urgency. Could these tiny organisms be the answer to our plastic prayers? The potential was certainly there, but more research was needed to understand how to optimize these bacteria for large-scale plastic degradation. While the discovery of plastic-eating bacteria is incredibly promising, it's important to remember that we're still in the early stages of research. Scientists are working tirelessly to understand exactly how efficient these bacteria are at breaking down plastic and whether they can be effectively deployed in the real world. Laboratory studies have shown promising results. For instance, one study found that Ideonella sakaiensis could degrade a thin film of PET plastic completely in just 6 weeks. While this might seem slow, it's significantly faster than the hundreds of years it takes for PET to break down naturally in the environment. However, the real challenge lies in scaling up these laboratory successes to tackle the massive amounts of plastic waste accumulating in our oceans and landfills. Factors like temperature, pH levels, and the presence of other microorganisms can all impact the efficiency of these bacteria. More research is needed to determine the optimal conditions for these bacteria to thrive and effectively degrade plastic in real-world environments. The discovery of plastic-eating bacteria offers a beacon of hope for the future of our oceans. Imagine a world where plastic waste is no longer a threat to marine life, where our beaches are pristine and our oceans teem with healthy coral reefs. While we still have a long way to go before this vision becomes a reality, the potential is there. Scientists are exploring ways to enhance the plastic-degrading abilities of these bacteria, perhaps through genetic engineering or by creating ideal environments for them to thrive. The discovery of plastic-eating bacteria is a potent reminder that nature often holds the solutions to the problems we create. It's also a call to action. While these bacteria offer a glimmer of hope, we cannot solely rely on them to clean up our mess. We must reduce our plastic consumption, improve waste management systems, and continue to explore innovative solutions to address this global crisis. The future of our oceans